Welcome to In 5 Minutes. The agenda of this clip is to draw a transistor level diagram or implement the schematic at the transistor level for the expression of sum in terms of Cout bar. Okay, let's get started here. In the previous clip, we have already derived this expression where sum is equal to ABC plus A plus B plus C, the whole bracket, into Cout bar. Now we want to implement this at the transistor level. There will be a lot of transistors. Please don't get intimidated by it. It's a very straightforward implementation. And that's the reason, to make it simpler for you, I have labeled all the parts which we'll be implementing in terms of first, second, third, fourth and fifth. So we'll get started with the implementation of Cout bar. We have already seen this in the previous clip, that Cout is nothing but AB plus BC plus AC, which is nothing but AB plus C into A plus B. Here, wherever I have written C, that's nothing but C in, so let's not forget that. In that clip, we also saw that if we implement this expression like this at the transistor level, what we will get is nothing but Cout bar, for the simple reason being that we have already studied that for CMOS implementation, if there is no bar, we have the habit of putting double bar. This upper bar will give us the inversion, whereas the lower bar will be simplified using De Morgan's. Again, I am repeating, the upper bar gives us the inversion. So in case when there is no bar, what will happen is we'll get an inverted output. So what we will get here is nothing but Cout equal to, or if we implement this, what we will get at the transistor level would be nothing but Cout bar. In order to get Cout, we need to connect an inverter at the output. Just summarizing everything in another few seconds. We know that the expression of Cout is nothing but AB plus BC plus AC. This is the expression. We also know, on simplifying, we'll get that as nothing but AB plus C, A plus B. The C is nothing but C in everywhere. In the previous clips, we have seen that if we have an expression which does not have a bar on the top of it, we tend to put double bar. When we do put double bar, the upper bar will give us the inversion, whereas the lower bar will be simplified using De Morgan's. The lower bar is used for simplifying for De Morgan's, and the upper bar gives us the inversion. In case we don't get the upper bar, or there is no bar present, whatever we implement will nothing but an inverted output. We have already discussed this in the clips of implementing Cout. So here, what we need to understand is when I implement this in my pull down, it will be nothing but my Cout bar. So let's quickly implement equation number 1. Let's implement that. A in parallel to B, because it's A plus B. This is A plus B. The whole thing is in series with C. So series. So this completes this implementation, which in turn is parallel to, plus means parallel to A and B. And is nothing but series again. So this is nothing but A and B. So this becomes my pull down circuit, or the circuit comprising of NMOS. We also know that an adder is a symmetric circuit. A symmetric circuit means the pull down will be exactly same like my pull up, or my pull up will be exactly same like my pull down. Again, we have seen this in the previous clips. Let's quickly do that. So A in parallel to B, which in turn would be in series with C. This entire thing is in parallel to A, which is in turn series with B. Remember, all these are PMOSes because it's a pull-up network, and this becomes my pull-up network which will be connected, and the output is taken between the two of them. And as we just said, the output won't be Cout, but the output would be Cout bar, because we don't have the inversion here. Again, you can refer to the previous clips to what I'm talking. So here I got this Cout bar implemented. So the first thing is done, very straightforward. Now this Cout bar, as you see, is in series, dot means series, to A plus B plus C. A plus B plus C is nothing but A parallel to B parallel to C. So I'm going to draw it here only. I'm just going to make my diagram smaller so that I can incorporate all that. So remember that this output is nothing but Cout bar. We have already got that.